what happens in Colorado is that we typically build our snowpack fairly slowly. In the beginning of the year, we may have kind of pockets of weak snow near the ground that formed in, say, October, early November, and then as you get storms that come in on them, that's going to increase the danger, and that may be why you say you see that peak in the beginning. As you get farther into the winter, we'll get a deeper snowpack, and whether that becomes dangerous or not really depends on what sort of layers we have in the snowpack, and are we producing weak layers in the snowpack. Each time a snowstorm comes in, that danger is going to spike up based on how big of a weather event it is and what sort of elements we have in the snowpack before that. And then that danger level is going to ramp down, and the nature of that decrease in danger depends on the structure of the snowpack, whether we have these very weak layers or not. So in a year like last year, where we have a fairly deep snowpack and not that many buried weak layers, you might see kind of quick increases and quick decreases. In a year like this, where we have a really bad weak snowpack, you're going to see fairly quick increases and then very, very slow decreases. And really what we've been seeing in the last couple of weeks here is that the avalanche danger is rising and falling with each weather event, but we're staying within that band of considerable, level 3, the entire time. So the map is orange all the time, even though the danger is actually increasing and decreasing each week.
But it's increasing and decreasing within the parameters that you consider considerable.
That's right.
And considerable, it seems like, is the most dangerous time in terms of statistic fatalities and injuries. Is that the case?
Yeah, it's in Colorado. I think it's kind of there's a tiebreaker between moderate and considerable. Those two are kind of the most dangerous. I think if you looked at the statistics over a long period of time, moderate would probably win. If you looked at maybe the last 10 years or something, it's probably more considerable, and that has more to do with the definitions of the danger scale than anything else. But in general, those middle bands are the more dangerous. And the reason for that is that when the avalanche danger is low, you can go a lot of places and not trigger an avalanche. When the avalanche danger is high, it's typically pretty obvious. You're seeing natural avalanches. There's a lot of signs of instability, and people are typically pretty careful. In the middle bands, considerable and to a certain extent moderate, that's where you can go out on those bluebird days where it's calm, there's deep powder snow, the weather is beautiful, you're there with your friends, everything seems fine, but there's places where you can trigger an avalanche. The signs may not be so obvious to you, and that's where you have to use really route finding to try to stay safe. So that middle period is really dangerous because you don't have obvious signs of instability, but you still have potentially fairly dangerous conditions. Continental snow climate is characterized by a relatively thin snowpack, and it's relatively thin in Colorado because we're very far away from the oceans and we don't have a lot of moisture that gets up here. Also, we have a lot of wind because we have fairly high mountains with fairly high elevation, so that also erodes the snowpack in a lot of places. We have fairly cold temperatures because, again, we have mountains with very high elevation. So that thin snowpack with cold temperatures is really the essence of the continental snow climate, and then you kind of throw in all the wind in Colorado, and it makes for an interesting but potentially dangerous snowpack. It's the avalanche cycles take on a different time characteristic than they would, say, in the Cascades or the Sierra. A place that's close to the oceans has a maritime snowpack that has very deep, accumulates deep snowpacks each year with relatively mild temperatures. We develop structural weaknesses in the snowpack that persist for days, weeks, and months because of the thin snowpack and the relatively cold temperatures that we get, for the most part. There's also some radiation factors that play in there. But the thing that really solidifies our approach to avalanches in Colorado is that we know that we form these persistent weaknesses that stay in the snowpack for days, weeks, and potentially months, and can be problems for us. We can have avalanches on a layer that formed in the end of February. We can have avalanches that formed on a layer at Christmas.
Okay.
And in other snow climates, depending on the year, they would see less to none of that.
And so why is it that these layers aren't starting to come together and form? What is keeping them apart?
It really has to do with snow metamorphism, and that's probably more you want to go than you want to go into in a short course. But the way that the water mass moves through the ice and air matrix will create structures that are inherently weak or inherently strong.
Mm-hmm. So if a Colorado skier went out to Washington, let's say, then would they have a better likelihood of having a solid base? I mean, I know every day it's different.
If a Colorado skier goes out to Washington,
mm-hmm.
they're going to ski really low angle slopes, just like they do in Colorado, and be terrified when the locals want to take them onto the runs they ski every day, because they're going to be of a terrain characteristics that the Colorado skier would typically stay away from. And it's probably going to be fine for them to go do that, but they're going to feel very uncomfortable because they're used to approaching terrain in a much more conservative way, because the margin for error that they need to stay alive in Colorado potentially is wider than what you would need in a different mountain range.